Good evening, friends. Good evening, friends. Welcome to this lecture series, Manufacturing Technology Second and Lecture Unit First, Lecture 11, Metal Cutting Operation. Agenda for today present in this video: diamond, cubic boron and nitride (CBN). Okay. Thermal aspect, only thermal aspect, total work and thermocouples. Analytical determination of the temperature in a metal cutting. Tool wear and tool life. What is the tool wear and tool life? I discuss for above. Tool life. Okay, these are topic are very present. Okay, the diamond. What is the diamond? Diamond is the very popular. Diamond is the very popular materials and hard and very popular materials is the basic famous of the electrical and mechanical properties of the diamond. The hardness of the diamond materials is the 8,000 kg per mm square, and the material that can be used for the cutting metals. The diamond material is also used for the in the manufacturing industry by form of the tool metal cutting operation. Okay, it has most of the desirable property of the cutting tools material, such that the hardness of the good thermal conductivity of the diamond materials and the very high melting point of the diamond and very hardness of the very hard and good wear resistance of the this is the property of the diamond materials. However, the factor that is the high against to the diamond is the also present in the porosity and oxidation in the allotropic transformation to the graphite above the temperature of the 700 degrees Celsius, very high brittleness, and the difficult to the materials is the sustainable of the cutting tool materials. The tools is the very hard and very sharp of the working for the cutting of the metals, and they are used with the negative of the right angles. This is the diamond tool materials is the also working for the in negative right angles mechanical hardness the material, while the positive and right angle is the 15 degree and can be used for the soft of the material with the cutting tool of the very high hard of the tools. They cannot be used the machining of the low carbon steels and titanium, such that and diamond materials, and other is the application of the materials in form of the tools of the metals. The titanium and nickel, cobalts and zirconium, because of the possible for the reaction with the work for the metals. I before discuss for the diamond materials. The diamond materials is the very hard materials, and the melting point of the temperature of the diamond is the 4,000 degrees Celsius above, and the basic working of the diamond tool materials is the 700 degrees Celsius is the normal for the is the existing in the all the properties of the diamond materials. The diamond tool materials diamond tools is also used in the -5 degree or right angles and positive in 0 right angles, and the working also for the positive 15 degrees of the right angles. The cubic boron nitride material, this is the also very popular materials, is the very hard, and the materials is the diamond is the similarly to the hardness of the material is the cubic boron nitride is the 4700 kilogram per mm square. It is not natural materials. The product for the elaborate of the research in the temperature is high high pressure process similar to the making of the artificial of the diamond materials. This is the carbon boron nitride is the artificial diamond materials. Okay. Comparison for the I discuss for the comparison of the other diamond materials in the artificial diamond materials. The aluminum alloy is the composition of the aluminum alloy is the 11% of the silicon, less than the 11%. The cutting speed of this tool materials is the 300 to the 3000 meter per mm square, okay, per minute. Depth of the cut is the 5 mm up to the 4 mm. Feed rate of the diamond materials is the 0.10 to the 0.50, okay, mm of the SI, and the particle for the 15 to 13% of the silicon is added to the composition of this material. And the cutting, this is the materials is the cutting speed of the copper, brass and bronze is the mm, 600 to 1200. Cutting speed is the 600 to 1200, and depth of cut in mm is the up to the 3 mm. The feed rate angle is the 0.10 to 0.50 mm per revolution. The carbon, brass and bronze material, and carbon and graphite is this is the materials as the cutting, this is the materials of tool is cutting speed of the 100 to the 400 is a meter per mm, meter per meter per minute, okay. And the depth of the cut is the up to the 3 mm, and the feed rate of the mm per revolution 0.10 to 0.50. Okay. Standard of the carbide is the cutting speed of the materials is the meter per minute is the 10 to 14, and the depth of the cut of the material is the 0.5 mm, and the feed rate of the material is 0.10 to 0.15 meter per revolution. Green carbide green carbide is the also material, and the depth of the cut is this, and the feed rate of the meter for is this. These green ceramic materials are so far the speed of the meter 100 to 600 meter per mm, and depth of cut depth up to the 2 mm, and the feed rate of the meter mm per revolution is the 0.5 to 0. And plastic of the composite, and the cutting speed of the 10 to 1000 meter per mm, and there is also used for the up to the depth of the cut of the material is the 3, and the other is thermal aspect. What is the thermal temperature? The measurement of the temperature of the tool materials in the the of the Thomas Benjamins of the Thomas in 1980, 1790 and conducted to the first experiment of the machine tool in the research of this experiment and measurement of the temperature of the cutting tools of the during for the boring of the brass was common. He observed that all the mechanical energy is converted into the thermal energy it is likely to more than 1% of the work done is stored as the elastic energy, which can be neglected. There is the remaining of the work for the 99% goes through the heat is the chief and tool of the hard work. The chemical energy is also converted in the form of the work in the shear plane for the also the more than the mechanical energy also for is converted in the heat generated because the internal friction tool and the friction between the tools and workpiece is the both tool and workpiece in between the friction is the also loss of the mechanical energy. This is account for the 60 to 75% of the total heat generated to the mechanical energy. The friction as the chief of tool interface to the tools and between the tools and the workpiece in the interface of the generated to the friction is the up to the 15 to 25% of the heat generated to the total heat or total energy or mechanical energy of the heat. The friction at the tool work interface which the heat of order to the 10% of the heat. The thermal aspect is continue present. The metal in the area of heated to the cutting is the tool is observed for the converted into the resulting temperature is the high for the plastic flow of the temperature the heat. There are the number of method for using in the find out the measurement of the temperature and heat of the the sum of the application of the methods is used in the measurement of temperature and radiation of the pyrometers. Radiation of the pyrometers is radiation of the parameters and embedded to the thermocouples. The second of the method in the operation of the embedded of the thermocouples and temperature sensitive of point. The temperature or sensitive point of the materials in the temperature for the colors. The also use for the method in the temperature for the colors. Indirect calorimeter for techniques and the indirect calorimeters calorimetric for the techniques is also used in the measurement of temperature or tool materials tools measurement of the measurement of temperature tools and in the the total work for couples of all the methods is work for the couples and techniques were also used in the method usually for the use in the measurement of the temperature of the tool material and workpiece. Tool work temperature also the in the discuss for the continue of the tool and work material for similar the temperature is cutting zone is the higher than the rest of the tool work of the material. Hence the total work contact area save to the hot of the junction of the thermoelectric circuit for the use in the methods of the step by the calibrating for the tool chip and thermocouples used in the measurement of temperature tool temperature the generated to the type of the proportional of the temperature not not and the ideal thermocouple which means EMF electromotive force is the help of electromotive force in the generated to the is the circuit in the circuit for also calibrated in it need to always the straight line of the what for the calibration process for the also done in the stationary situation. This is a method of the also situation in the metal for cutting tools of the situation. This whole process in apply for the measurement of temperature, tool temperature, and the interface of the friction is generated to the workpiece and the tools in between them. It is the analytical techniques for producing the average temperature as well as the temperature or contribution. This is the reading to find out the measurement of temperature is the this is the thermocouple electric thermocouples are used in the sum of point it discussed for above. There is the also potentiometers. This is the use of potentiometers in the this is the workpiece and this is the tool of the area, and this is the generated to the chief of the workpiece and lead to path of the tool tip of the materials and wire of the copper wire. This is the tool in the connected to the copper wire, and copper wire is also connected to the reading of the parameter, reading of the holes reading is recorded to the in the generator room. This is the charcoal of the corolometer and aluminum. This is the also used in the heating of the coils is the also parameter. Insulation, the whole of the workpiece is also insulated. This insulated is the uh, safety for the no heat transfer of the external of the workpiece. Okay, this is the use for the technique of the also used for insulate no transfer of heat. The storage for the heat is continue in this operation. Analytical determine of the temperature in the metal cutting. As the result, the temperature of the tool tip is the highest. Also for the tool materials, tools is the temperature is very high tip, and the temperature when the wood will conducted through the tool along with the rack face of as well as the rack and rack face of the tool. The most of the tool wear in mechanisms is the thermally are invited to which the increase the wear along for the rack face of the workpiece in the tools face of the the total for the determine of the temperature for the tools is the T equal to the also used for analytical method is the T equal to 0.4 and Ta tool temperature. Okay, Vd upon K by K power 1 by 3, where this is the formula used for the 0.4 is the constant value. Okay, this 0.4 is the measurement of the constant value, and there are the K the thermal diffusibility of the work and materials in square. Okay, the specific heat C is the specific heat of the rho is the density in also not mentioned for this formula, and but I this is the function is used for the against formula. A specific cutting energy us is given to the equation for also drive for so the adiabatic temperature ta is the adiabatic temperature the us upon the rho c. Okay, ta the find of the value ta. The Ta value, the adiabatic temperature of the equation is sorry. The specific cutting energy US and the by using above equation the adiabatic temperature Ta बराबर US upon rho C. Okay, this is Ta is the adiabatic temperature of the tool material. Analytical determination of the temperature in the metal cutting. This equation provided the reasonable estimate for the temperature for rack angle between the -5 to the positive of the 15 degree. More complex analytical determination of the method has been developed in the temperature for the tool and workpiece in between the interface. Space for the of the book in the cutting process, the parameter speed and feed rate, depth, and the all the measurement is the very constant parameters in the cutting tool. Temperature generated to of the cutting for the the temperature is the point of the tools controls. The total energy input to the metal cutting operation is the this is the temperature con, con, contouring in the cutting tool of the both head. This is the workpiece. Okay, this is the workpiece of the this is the chip formation. This is the tool. Okay, tool, and this is the generated to the chills of the cutting. This more generated of the chips in this operation. The tool is the also in the 4 degree or 5 degree to the chip working for the also generated in the temperature for the this is the shear zone. Okay, this is the shear zones of the in the the main of the generated to the tools generated to the mechanical energy converted into the heat in this point. Okay, generated to the heat in this the tool tip of the fration. Tool wear and tool life. What is the tool life? The first of all the discuss for the tool wear, the which uses to the tool over the long time. They are subjected to the wear. The types of wear found in the cutting tools. There are the two major types of the wear found in the tools. They are crater wear. What this is the figure also present in the this is the this is the workpiece. Okay, and this is the interface of the tools, and workpiece is the flank wear, and this is the flank face of this is the tool of the flank face of the tools and the tools, and this is the tools is the interface of the chip. This is the chip, the rack face of the this is the this is the measure of the tools, measure of the tools tip of the this is the chip. Also this is the rack face of the chip, and the crater wear. This is the this is the generated this is area is the crater wear area. Okay, typical the parameters present in the cutting tools. The crater on the rack face of the more less circle or the more less. The crater does not always extend it to the tool tip, but may not be discussed for the tool tip. It increases the cutting face, modifies of the tools, geometry for the sort of the tools. Thank you so much. Dear friends, subscribe this channels and more created to your our knowledge. Okay, thank you so much.